This video will walk you through the steps as to how to complete problems using polynomial long division. This is one of the two types of division you will learn in the unit on polynomial functions. You've previously learned in previous courses and reviewed earlier this year how to use polynomials to add, subtract, and multiply. Division is the one thing you have not learned how to do with them because there are multiple ways to divide polynomials, and the processes themselves are a little bit more complicated than adding, subtracting, or multiplying. So this video will walk you through a couple different types of problems you might see in regards to long division. Now, process for long division is very similar to the long division you learned way back in elementary school, which you probably haven't used in years, but it is a very similar process as you would to do long division with regular numbers. It's just that now we've got terms with variables. So this first problem here is going to walk you through the steps as to how we're going to divide two polynomials with one another. So I'm going to use a couple of terms with this here that will be helpful to know as I reference them throughout the video. We've got x cubed minus 4x squared minus 9x plus 7 divided by x plus 7. What we have here, in using some official math words here, whatever we are starting our problem with here is our dividend. Whatever we're dividing by is referred to as the divisor. Our answer will be composed of two things. It'll be composed of what we call the quotient, and if we have any remaining terms left over, we'll have our remainder to tack on as well. Only reason I'm referencing these is because you may hear me say them throughout the video. The dividend is what we're starting with. The divisor is what we're actually dividing by. So let's go ahead and work through how do we divide polynomials. So I'm going to use a setup that looks very similar to what you may or may not remember from long division many years ago. So I'm going to set this up where I have a little elbow box here. I'm going to put my dividend underneath and my divisor on the outside. Now, my goal through this problem is to divide this as far as I can and to figure out what the quotient would be. Now, the way that we set this up is this is going to take, you'll see, it's the same pattern every single time. Once you do it a couple of times, it's about following the same process every single term throughout your problem. So let's figure out how we're going to divide this here. First thing I'm going to worry about here is the first term of my dividend, which is x cubed, and the first term of my divisor, which is the x. What I want to figure out is how many times I can divide x into x cubed. If I divide the x into x cubed, what would be left? This case, x cubed divided by x gets me x squared. Once I figure out how the first term of each, the dividend and divisor, if I were to divide them, what that result would be, I'm going to take that result and multiply it by both terms of the divisor. So I'm going to multiply x squared and x and get x cubed. I'm going to multiply x squared and 7 and get 7x squared. Once I get these terms, you notice that I put them underneath and I try to line it up with the like terms, because in long division, whenever you figure out these terms, you subtract them away from whatever your dividend is. So these two terms I just found here, I'm going to subtract. So you'll notice I put parentheses around these terms and the subtraction sign outside of it. The way that you need to talk this through is to figure out, okay, x cubed up at the top minus the x cubed underneath. Well, x cubed minus x cubed cancels out. Now I have negative 4x squared minus 7x squared. That's going to leave me with negative 11x squared. To continue my long division process, I'm going to pull down the next term, which is negative 9x, and now I'm going to repeat the process that I started with. So I'm going to take the negative 11x squared, divide out the x from my divisor. That leaves me with negative 11x. I'm going to take that negative 11x, that result, multiply by both terms in my divisor. So negative 11x times x gets me negative 11x squared. Negative 11x times 7 is negative 77x. Once again, once I get these terms, I'm going to subtract them away from what I had down here in the bottom. So negative 11x minus negative 11x, that's going to cancel out because subtracting a negative gets you a positive, so that goes away. Negative 9x minus negative 77x, that's the same as negative 9 plus 77. That gets me 68x. If I have more terms left in my dividend, I'm going to continue to pull them down until there's nothing more to pull down. So I'm going to pull down the plus 7, and I'm going to repeat this process one more time. So again, I look at the front terms, 68x divided by x. If I do that, I'm going to have a positive 68. And now it's just a matter of repeating the same process. 68 times x, 68x, 68 times 7, 476. And again, I'm going to subtract those things away. So 68x minus 68x is going to cancel. 7 minus 476 is negative 469. I have no more things to pull down from my dividend, so my problem is now finished. It's just a matter of now taking this and writing it in the correct way. So my final answer is to take what I got as the quotient, so the stuff on top of the box, x squared minus 11x plus 68. My remainder was negative 469. To show my remainder, I'll have minus, I'm going to take the 469 over my divisor, x plus 7. And that is how you divide polynomials. So it's a little bit complicated of a process because there's a lot of moving terms, a lot of different types of x's, or whatever variable you use. It's just a matter of keeping everything aligned. It's a lot of the same pattern, though, over and over again. And I'm going to go through how to do this with a couple more problems if you continue to watch the video here. So it's the same process, but what we need to make sure of is that we have all of our appropriate terms in standard form, and everything is in the order that it's supposed to be. Numbers here in this case, I just kind of threw some numbers down and saw what happened here. This case, we had a pretty big remainder. We had some pretty big numbers as part of our answer. That won't always be the case, but just depends on what numbers you're messing with. It depends on your result. So that is the first example I wanted to go over here. If we take a look here at the next example, you'll notice there's one very big difference with our polynomials that are here. So we have our dividend, 5x cubed minus 8x plus 7. We have our divisor, x minus 3. The one thing you have to make sure of is when you do polynomial long division, you have to have, quote unquote, all the terms you're supposed to have in order from highest exponent to lowest. Basically, if you have a problem, let's say in this case with an x cubed, you should have an x cubed, an x squared, an x, and a constant. If you look at the dividend, there is no x squared term. Not that you can see. If you are missing a term like that, so in this case, the dividend's missing an x squared, you're going to rewrite it so that there is an x squared. Since there is no x squared to be seen, we are going to call it 0x squared because it wasn't there in the first place, but we need that placeholder. The reason why you need a placeholder is because you need all of your terms to be in alignment. If you don't have the placeholder, it makes it very hard to divide this accurately, and honestly, you'll probably make a mistake without having it there. So if you're missing a term like that in the middle where your exponents seem to be skipping something, you need to make sure it's there. If my divisor, x minus 3, that's in good shape. That's a nice and order, logical, all in good shape. So what I'm going to do to divide this is once I make sure that placeholder's in, is I'm going to repeat the exact same process I just went through. Only thing is, I'm going to make sure my dividend has written in the placeholder. So this is what my problem is going to look like. And all I'm going to do from here is repeat the exact same process that I did in the previous problem. So if you want to pause the video here, try it yourself, feel free. Otherwise, I'm going to talk through the steps once again. So take a look at your front terms. We're going to do 5x cubed divided by the front term of our divisor, the x. So 5x cubed divided by x gives me 5x squared. Take that result, multiply by both terms in the divisor. So we'll have 5x cubed when I multiply, 5x squared and x. 5x squared times negative 3 is negative 15x squared. Once again, I'm going to subtract those away. So the 5x cubes will cancel. 0x squared minus negative 15 becomes a positive 15x squared. Pull down your next term in your dividend and repeat the process. So 15x squared, take out the x, you're left with positive 15x. Multiply that, 15x times x gets you back to 15x squared. 15x times negative 3 gets you negative 45x. Once again, we subtract our terms, so the 15x squareds will cancel. Negative 8x minus negative 45x is a positive 37x. And we pull down our 7. Now our last wave of this here, 37x divided by x is 37. And now we multiply it back through. 37 times x is 37x. 37 times negative 3 is negative 111. Once again, we subtract, and we're left with a remainder of positive 118. So I get a final answer. I'm going to go ahead and write what I got above the box here. So 5x squared plus 15x plus 37. I have a positive 118 as a remainder, so we have plus 118. Make sure, again, you write the remainder over top the divisor. So my final answer is 5x squared plus 15x plus 37 plus 118 over x minus 3. Last example here I'm going to show you is exactly the same type of problem I just walked through, except your missing placeholder is going to be in the divisor, not in the dividend. But you're going to see it's the exact same type of logic here. So if you look at the dividend, we have a fourth power, a third, a second, a first, and a constant with no exponent. If you look at the divisor, we have an x squared and then a 5. It's missing a regular x, okay? So it's missing that linear term. What we're going to do here is I'm going to rewrite it so that it does show an x. And again, when we pop in a placeholder like that, we are putting a 0 with it because it wasn't there in the first place. If it disappeared completely, the only way to get rid of an x is to put a 0 with it. So when I write out my problem, my divisor on the outside is going to be x squared plus 0x plus 5. And my dividend, again, I can just kind of copy what's there because all my exponents are there. Nice in order, 4, 3, 2, 1, 0. So in a problem like this, again, there's a lot of terms, but it's all the same idea. It doesn't matter if your divisor is a binomial like the first two. We have a trinomial here with the x squared, the 0x, and the 5. It doesn't really matter how big or small they are. You follow the exact same process. So once again, start with the front terms. X fourth, take out x squared, you have an x squared left over. Take that x squared and multiply it to everything. So x squared times x squared is x to the fourth. X squared times 0x is 0x to the third. X squared times 5 is 5x squared. So in this case here, you end up with 3 terms that you're going to subtract away, but no big deal. Same exact idea. So the x to the fourths will cancel. 7x cubed minus 0x cubed is 7x cubed. 8x squared minus 5x squared is positive 3x squared. And once again, you go ahead and pull down your next term. Let's go ahead and divide out the front things again. So 7x cubed, divide out the x squared. You have a 7x. Multiply that 7x to everything, so you end up with 7x cubed. It's positive 0x squared. And a positive 35x. You'll subtract them away. The 7x cubes will cancel. You'll have 3x squared when you subtract the x squared terms together. When you subtract the x terms together, you'll have negative 37x. And we'll pull down our final term, the negative 1. Again, we divide out the fronts. 3x squared divided by x squared is a positive 3. Multiply that 3 to everything, you'll end up with 3x squared plus 0x plus 15. Once again, we subtract. The 3x squareds will cancel. You'll have negative 37x once you subtract. When you subtract the constants, you'll have negative 16. There's nothing more to pull down, so your problem is finished. So your final answer, we take what's above the box, the x squared plus 7x plus 3. Again, we have an expression that starts with a negative number, so I'm just going to go ahead and put the minus sign. Okay. You could also write it, if you want to, as a plus negative. So you can also write it like this, which is totally fine. Plus negative 37x minus 16. Just make sure, again, you put your remainder over your divisor. You can go ahead and use the original divisor without the 0x. If you put the 0x back in it, that's not wrong. It means all the same thing, but you end up with that as your final answer. So with polynomial long division, Long and short of it is you have to practice it. Much like you did back in elementary school when you learned long division in the first place before you got handed a calculator, it's the same idea. You just have to practice the pattern of it over and over again. But that, again, walks you through if you have everything that you need or if you need placeholders. Again, this is your process on how to solve problems using polynomial long division.